Okay. So let's start with some basic questions. Something like this. Example 1. So solve the equation. So we're solving stuff. And we have to be careful if we're solving for between one period or just n periods. So I want to do both. That way you know how to do all the questions in this section. So it starts off pretty easy. Well, actually, it starts off easier than this, but I'm going to go ahead and start here. So the first step is isolate sine. Then you get rid of that 7, right? Subtract 7 on both sides. That gets me to here. Divide by 4, both sides. That gets me to here, right? So then the question becomes, all right, which theta will give me a half, right? So we can introduce inverse functions to help us out. So in a way, you could say, you know what? If I do the inverse of both sides, we should be able to solve for the theta, right? Then theta is equal to sine inverse 1/2. Okay. So where is theta 1? This theta value. This should be 30 degrees, correct?
Yes.
Why would you need to do that if you already had sine theta equals 1/2? Couldn't you just use the chart and look it up?
You can, but I'm not going to give you simple numbers.
Okay.
I'm going to give you stuff that's not on the circle.
Okay.
Eventually. That's a good question. Yeah, you never know what's going to be in there. So this is a procedure for any type of answer, any type of question, right? So we're going to call this theta 1. This is going to be 30 degrees. So once you find the first one, remember that inverse only gives you the right half of the circle, right? But to find the other half, what you could do is subtract from 180, the angle you found, to find the second answer. And yeah, these are both on the circle, right? We know that's going to be a half here and there. But if it wasn't a pretty angle or a pretty value, you would still do this approach, okay? Now, the questions are going to be asked in different ways, so I'm going to go ahead and be more clear. So let's say part A says solve it. Solve this on the interval 0 to theta to 2 pi, right? From 0 to 2 pi, they want to know all the angles that give you 1/2. So still example 1, but they're going to phrase it this way. If they phrase it this way, you will have a, I should remove that equal to here. It's technically not what I want. All right. So it has to be between one period, which only gives you these two answers. And you would be done, right? You'd have only 2. But if the question is asked this way, solve it for all theta, or they don't even mention a period, or they just say solve. Then you have to solve it for n periods. What you're going to do is take your answer, actually, sorry, we use degrees, so we use degrees. So we take the first one and we add 2k pi, where k is an element of the integers. In English, this is k is an integer. So since we're not restricting it, then that means I can keep going around and around the circle as many times as I want, k times, and I can keep landing here, right? So 0 would be here. With k is 0, then I get 30, right? If k is 1, then I add 360 to this. So that should actually be sometime in degrees, right? Let's keep it with degrees. I'll go ahead and put both in a second. 360 degrees times k, which is the same as pi 6 plus 2k pi, or 2 pi k, however they write it. Okay. Do you see why this is necessary? Or what this is saying, the 360k? Okay, so then you'll do the same thing for theta 2.
What does
So you
it say?
take, what's up?
K is in what?
Integer.
Okay.
So there's capital I right here. So this I don't know if I've written this before. K epsilon capital I, that means k is an element of the integers.
Oh, okay.
So in plain English, k is just an integer. -1, -2, -3, or 0, 1, 2, 3. Any of those are okay. No fractions, no square roots, just whole numbers that are negative and positive, but also 0 is cool. That's what integer means, right? You guys remember the definition of I?
Yeah.
Okay, just in case. There it is again. So you do the same deal for this guy. So just add 360 times some k. And again, k is an integer. In radians, this would be 5 pi 6 plus 2k pi. So the questions are not going to be this difficult. I'm just solving them in every possible way. That way, no matter how they ask you, you'll be good. Okay. You guys have any questions?
What's that little symbol between the K and the I mean? Or what
Element
is it
of
actually?
it's
Okay.
supposed to be a lowercase epsilon, but the handwriting is a
Okay.
little bad. It's supposed to look kind of like this, with a C with a little thing in there, or a
Okay.
curved. But anyway, whenever you see an epsilon in math books, usually that means element of. So K is some I, in other words.
Got it. Thank you.
Like if I were to put K element R, capital R, then that would be K is any real number. But we're not talking about real numbers, we're talking about specific integers, only integers. All right, another example, do the same type of question. Exactly the same, except we're solving something a little bit different. To solve 8 cosine squared theta equal to 6. So part A, solve it on the interval 0 to 2 pi. Part B, solve for all theta. And periods. All right, so first of all, let's solve this guy and then we'll go from there, right? So here we go. Before you start messing with the cosine, you gotta get rid of the 8. Divide both sides by 8. We'll get to here. So that'll be 6/8, right? Which is cosine squared equal to, what is that? 3/4? 3/4?
Fourths.
Yeah, thanks. Okay, so we gotta get rid of that square. So you're gonna square root both sides, right? So that's gonna give us plus or minus. And so here we go. So I have to tack on this plus or minus whenever you square root both sides. So we get square root 3/2. And again, this is on the circle, but let's approach it like we did before. So we have cosine theta equal to plus or minus. Really, we have two questions. Let's write it as two separate equations so it makes more sense. So we have positive root 3/2, and we have negative root 3/2, right? So introduce your cosine inverse. Sorry, I wrote it backwards. Cosine inverse of both sides, cosine inverse. That'll give me theta equal to, I believe that will be what? Is that pi over 6?
Yes. It's
Pi
5/6. Yeah.
Cool, thank you. All right, so we found the first theta. I'm writing theta 1 just so we know that's one of the solutions, right? And let me straighten this out. Okay. So now we'll do the same over here. Cosine inverse of cosine theta is equal to cosine inverse of negative root 3/2. So theta will be equal to 5 pi 6, right? Okay. So that would be for one period. So the answer for one period would be theta 1 and theta 2, right? For two periods, actually, sorry, before we move on, I'm getting ahead of myself. There's more than 2, isn't there?
Yeah.
One moment. Okay. I'm going to call this, well, that's fine. So theta 1 is pi over 6, right? So the other one should be pi minus pi over 6. And theta 2 is 5 pi over 6. Also, the numbering here does not matter, so don't worry about that. This should be pi minus 5 pi over 6. Okay. All right, so here we go. Theta 1, still the same. Theta 3, that will be 5 pi over 6.
We have
Right.
2 theta 3s.
Yeah, you're right. So doing this gave me that guy, so that didn't help me at all. Where is my note? Yeah, 1, 2, 3. Okay, so that didn't help. But let me check my stuff here. Cosine inverse of yeah, that's good. Sounds right. Okay. Okay. Double check this guy. Minus that. 7 pi.
Good.
Which will be 12 pi over 6 minus pi over 6, which gives us the other angle, 11 pi 6. Now our other guy, so that's theta 2 is still good. Theta 4, that should be 2 pi minus 5 pi over 6, which will still be 12 pi 6 minus 5 pi 6. So that should give us 7 pi 6. There we go. So our 3 thetas, or our set of thetas, will be pi over 6, 11 pi over 6, 5 pi over 6, and 7 pi over 6. So this would be part A in the interval 0 to 2 pi. That would be your set of solutions. For part B, you would have to add, either consolidate these guys or put plus 2k pi on each one of them. So this is part A. Part B. So real quick, it would not be wrong to tack on 2k pi to each one, but let me show you this circle. You can see what I'm thinking about here. Okay. So pi over 6 is the first one we found, right? You notice how 180 would give us the other one of the other answers, 7 pi 6. From here to here is 180 degrees, right? Or pi degrees. Now, if we look at the other solution we found, the first two solutions, the other one was 5 pi 6. 180 from here is root squared 3 over 2, right? So technically, you could just say this answer plus pi, because it'll just keep going to, if I keep doing 180 or pi degrees or radians, I'll keep landing here or there. So I can combine these into one answer, or I can put 2 pi plus 2 pi plus 2 pi. But you see what I'm saying? So technically, the answer could be written this way. Pi over 6 plus k pi. And the other solutions, we like this more official. I thought I picked an easy one to start off with. I did not. Sorry about that. I didn't want to jump into the deep water real quick, but here we are.
Sure it's not the sand trap?
Yeah, I know. The first one made sense though, right?
I guess it's only up, only down from here.
I hope so. Plus k pi. So this one takes care of, we said pi 6, right? And 7 pi 6. So I'm combining these two. So that's one set of thetas, and then the other theta would be, I'm going to choose 5 pi 6. Let's see, where's it at? Yeah. 5 pi 6 plus k pi. But if you feel like that's weird, you could technically write 2 pi k on each one. Okay. So let's do another example. It's a little bit more simple.
What's the difference between the example 1 and this one? Why is there 4 in this one and 2 in the other?
The reason 4 came out is because we had the plus or minus. So it really created 2 questions at the same time. You see that?
Okay.
Like if it was just this guy, it would have been solved the same way as the other one. Almost the same. But this forced me to create 2 sets.
Okay. 2 sets of 2.
Yeah.
Okay, I got you.
That plus or minus just really sucked. Sorry.
All right.
Let me go to the, yeah, okay. Here's another example. So 2 sine theta plus root 3 is equal to 0. Right, so an equation, so it's implying that you're solving. So part A, solve 0 to 2 pi. Part B, solve in general and periods. Okay, so this one will be similar to the first one. Just want to make sure we understand the basics first. So 2 sine theta plus square root 3, right? So we're going to subtract the root 3. And then divide by 2. Okay, so once you get here, we start looking into the inverse stuff. Okay, so sine inverse of sine theta is equal to sine inverse of negative root 3 over 2. So let's do it in degrees this time. So which degree would that be?
$60.
60?
Or 120, actually, it's negative.
Oh yeah, gives you negative 60. So it gives you negative 60, but we want a positive angle. So that would be same as 300, right? If you add 360 to the negative, you'll end up at the positive version. So 300. Double check here. Yeah, there it is. Okay. So then we have the first one. So we'll call that theta 1, 300 degrees. So theta 2 would be 180.
Wouldn't it be 150, 120?
Yeah, I think it should be. The first one is 300 degrees, and the other guy should be 240. Let's see here. No, it should be. Yeah, there it is. Sorry. Just doubted reality again. So it should be 300 minus 180. It should be 120 degrees. 120 would be the positive guy. 300. Let's see. It should be 4/5. Negative 6. Yeah, let's stop here for a moment. I need to check something. Something's not right. Take a small break. It's 6:50. Let's come back at 7:05-ish. Something's wrong in these notes. We'll just do what we did before, right? So the part A, the set of values that satisfy the equation between 0 and 2 pi will be just these two. Part B, we have to tack on the 2k pi. So the first set of thetas would be 300 plus 360k, where k is an element of the integers, and theta 2, 240 degrees plus 360 degrees times k.
Can you move it up some?
Yeah, sorry. There you go.
Thank you.
Okay. Do you have any questions on the finding in one period or in using n periods? N periods. Okay. So the next one is I think the hardest part of this section is expanding this to trig functions that are faster, like the periods, when the periods are shorter, because they can go around, they can hit these values multiple times within one period. So let me show you a procedure. And I'm going to skip one minor step just so we don't use up too much time here. So example 4. All right. I think it's 4. Yeah. Solving a trig equation involving a double angle. So suppose you have 2 theta equal to 1/2, right? So part A will actually be the harder part. Let's do part B first. I'm just going to switch them around just so you can see why. Solve for all theta. Okay. So what you do is basically, remember, we'll just use unit circle this time just to save some time here. So look at your circle. If not, I'll share one with you. So sine is 1/2 at pi thirds, right? And 5 pi 6. So we're going to use those guys to help us out.
Wouldn't it be? Oh, okay, never mind.
Oh, sorry, did I close it? There.
Looking at wrong.
Oh, okay. I thought I missed something for a second. All right, so one moment, grab my notes here. All right. So basically, what you do is set this theta equal to those values we talked about. So the first one we said sine is 1/2. We're at which angle? It's going to be pi over 6, right? Plus 2k pi. And then you have another one at 5 pi 6.
Are we looking at the y value for pi over 6?
Yeah, for sine, you always look at the y.
Okay.
So right now it's exactly this, very similar to the first question we did, right? But since you have 2 theta, you're going to go ahead and divide those 2 out. So theta will actually be pi 12ths plus k pi. And this other set, we'll call it 1 and 2 here. Now, I think we'll call it there. Just change it later. It'll be 5 pi 12ths plus k pi.
Why is it 2 theta?
That was, so in the question, it was a double angle. That's how it starts.
Okay.
So usually we had just some theta, right? When you do the sine inverse of both sides. So I skipped that
Mhm.
first step. So skipping to here, we have 2 theta, so we got to solve for theta. So dividing
Okay.
everything by 2 gets us here. You guys see where these numbers came from, everybody?
Yes.
Okay. So this would be the 2 sets for all theta. But when they restrict it to 1 period, that's when it gets difficult. All right, so part B will be the hard part. So within 1 period, how many thetas will there be? So I'm going to have to cycle through from 0 to probably 2. But it might be easier to graph it and see what's going on before we do anything. Because right now, we might not be able to imagine sine 2 theta. Okay. So y equals sine 2. All right. All right, so here's the sine 2x, right? 2 pi. Here's 0, pi fourths, pi halves. Here is 5 pi fourths, pi. Where is 2 pi? Okay, there. Okay, so there's 0. So from here to here is the interval that they're asking for, right? But since it's a double angle trig function, it's going to repeat itself a couple of times before it hits 2 pi. So it's going to hit the values it's asking for. In this question, the 1/2 value a few times, right? It's going to hit it. So here's half. So around here, so 1, 2, 3, 4 times. And then it hits the, yeah, so 1, 2, 3, 4. So it looks like it's going to be 4 answers before I even end the period. Okay. So because of that, we have to add, we have to let k equal 0, let k equal 1, let k equal 2 until we pass 2 pi. Once we pass 2 pi, then we know I should stop. So get back to the paper here. And so what you're going to do is we'll take both of them. So let k equal 0. So the first 2 answers, right? These are general solutions here. So for first theta, we will get pi 12ths, right? Plus 0. And then theta 2 will be 5 pi 12ths plus 0. So because I like k be 0. So I got my first set of answers. See what I mean? So then I was like, you know what, let's let k equal 1. So theta, we'll call this 3, will be pi 12ths plus, let's see here, 1 pi. So 12 pi 12ths plus pi will be what? 13 pi, right? Theta 4, same deal. So here's one answer, so don't get confused here. Another answer. One more. Oops, sorry. Let's go here. Not this one. Let's get theta 4, 5 pi 12 plus a single pi. That will be 17 pi 12, right? Okay, so now I have 1, 2, 3, 4 solutions. Based on the graph, I'm probably done. But we need to, if you're not sure, then we should check. So k equals 2 and see what happens, right? So do we have a theta 5 and 6? You take pi 12 and add 2 pi. So that would be 25 pi over 12, right? But is that bigger than 2 pi? And if it is, then you know I'm outside this range. But of course you can tell, right? 2 pi plus something, of course, is bigger than 2 pi. So I should stop right now. Do you see that? It almost doesn't make sense to keep going because if I let k be 2, adding anything to this will be above the interval that we're talking about.
I get it.
So this is too big. So don't do this. So you would stop at 0 and 1. From experience, I've noticed that when you do double, triple, or quadruple angles, all you have to do is say, all right, well, if it's double, then that means it's gonna have twice the answers, right? So the original only has 2 pairs, the new one should have 4. So if it's 2, I'm gonna go k equals 0 and 1. If it's 3, k will be 0, 1, 2. If it's 4 theta, then k would be 0, 1, 2, 3. So it's always one less than that value. So you'll stop accordingly. Okay. But the answer for part B will be all these little values. Okay. Does this make sense? Is there any parts here that are weird or confusing? I skipped the fraction step. That's all. That's how I got here, by the way.
The last number you have over here in B is 17? 17 pi over 12?
Mm-hmm.
Okay.
Yes. Okay. Okay. That's pretty much it for A3. Let me see if there's some other examples we could use. Oh, by the way, did I explain the extra credit to you guys? I can't remember.
No, you just sent us an email.
Okay. So I'll just explain one more time just in case. So the school requires me to test you guys on this assignment. It's has not really anything to do with pre-cal, and it's not for a grade, but they're requiring you to do it. So I'm giving you about 5 points or so on your exam for doing it. Either this exam or the next exam, doesn't matter. But all you have to do is put your banner ID on top in a CRM, which I already put in the description of the assignment. So what I want you to do is download the PDF, fill it out, and then re-upload it, and that's it. If you can name it after with your banner, that'd be great. You guys have any questions on it, on the assignment? The easiest way to show your steps would be to print it out, but if you can, then just try to type it in if possible.
So is it like a paper we're writing?
Yeah, so you're basically downloading like a worksheet, like with 2 problems on it, and then you just solve it. It's gonna ask you some basic questions, like problem solving. I think that's what they want to test is quantitative skills. So they want to see. Did that answer your question, or?
Yeah.
Okay. Alrighty. What was I doing? Oh yeah, look at it. Let's take another question.
Is version 1 the actual assignment?
Yes. Yeah, I think if you click on it, the PDF pops up, right? Like with a little car on it. Okay. 8-3. Yeah, it's due on the 12th.
That's the right PDF file, even though on the top it says fall 2019, correct?
One more time.
That PDF file for that extra credit assignment, it says fall 2019 on the top. It's still okay though, right?
Yeah, so you clicked on it. You clicked on version 1 and it says the fall 19, right? Yeah, that's fine.
Okay.
So the CRN is those the last 4 digits. I think I put it in parentheses. Okay. All right. I'll just pick this random one then. Homework was not loading. Okay. So let's suppose we have a question like this. This is example 5, right? Yeah. So here you have to use a calculator. There is no unit circle value. So that's what I was trying to prepare you for. So let's say you have cosine theta equal to -1/4, right? All right, so you would use your cosine inverse, or arc cosine, on both sides. And if you're in radians, you should get about approximately 1.8235. So then the next thing is trying to figure out, okay, which quadrant is that? Because if it's positive, then it has to be what? First quadrant or the third quadrant. Or sorry, first or fourth, right? So we find those values. Let's see here. What you can do is figure out approximately what is pi. It's about 3.14, right? So we know that's less than that guy. Pi over 2 is approximately, let's see here, about 1.57-ish. So we know that it is bigger than pi over 2, right? Less than pi, so this is going to be quadrant 2, right? Let's see here. Theta. Okay. Since it's negative, that makes sense because of the negative x value. Okay. So put this in English. Since 1.8235 is between pi over 2 and pi, doesn't look legible. Between pi over 2 and pi, then theta is in quadrant 2. Okay, that makes sense. The idea I'm trying to convey here. So since it's negative, then we're going to look at quadrant 2, which we just figured that out. But it's also negative in quadrant 3. So the idea, I'll try to draw you a picture here. So here's pi, right? Here's pi over 2. Here is our weirdo angle that we found. There's 0. So from here to here, it's about 1.8235 radians. Okay, so that's my write that a little better. My theta is approximately 1.8235. Now, if we were to do the coterminal angle, right? The coterminal angle would be pi minus 1.8235. So this angle, which we'll call it, let's call this approximately, let's say 1. So pi minus that will be about, right, it'll be about 1.3181. So from here to here, we have theta 1, using our ideas of coterminal stuff. Theta 1. All right. But what we really want is the angle down here, right? The one in the quadrant 3. So to find the actual answer, so this is our first answer. To find the other answer, You know what? I don't like calling it data 1. Call it something else like data with prime on it, quote. Right, data prime there. But to find, if this is the first angle, to find theta 2. There you go. Now this makes more sense to me. What you do is take this piece here and add it to pi to find that missing section. So pi plus the 1.3181 will give me the part that I need, which will be 4.4597. So the angle,
Please.
oh yeah, sorry. There we go. So getting all the way to there, right?
Couldn't you just do 2 pi minus 1.8235?
2 pi minus what?
1.8235.
Yeah, you can. I just want to draw you a picture to show you the ideas of coterminal, but that picture sucks. That one. All right, so that'll be theta 1, theta 2, this is theta 2. There we go. Theta 5 and theta 2 equal to 4.4597. So yeah, you said subtracting like from 2 pi like we did in the other example, right? Yes. So I don't want to do it 2 different ways. I don't know which one makes more sense. So you can use the ideas of coterminal to find both answers because you don't have the circle to guide you anymore. Or you can use the example that we did before by subtracting from the 2 pi when you're doing cosine. If you're doing sine, you should subtract from pi. Whatever makes more sense is fine. I just thought maybe the visual would be good. But this is when you have to use inverse. But all the other examples, we did not have to use inverse functions, technically. They were just in the background. Do you see what I'm saying? So technically, you could have just said, you know what, I got this with the calculator, right? So couldn't I just say 2 pi minus 1.8235, and yeah, that gives you the 4.4597. So this, I like doing it this way, but the book does it something like this. $4.459. All right. All right, guys. Well, we'll stop here. Yeah, I'll save the next section for tomorrow because the next one's very long. For Wednesday, rather. Now, try to have your exams ready latest. I'm going to say next Monday, but I'm going to try to do it this week. Okay.
Yes, sir. Thank you.
All right, guys. Well,
Thank
I'll
you.
see you Wednesday, and if you have any questions, you're welcome to stay for a bit.
Thank you. Bye.